Okay guys, so today we're going to go over parallel lines cut by transversal. There's a couple vocabulary words that I actually want you to write down in your composition book, so this would be part of your summary. So copy down the definition and definitely write the example. Let's begin. The first one is a transversal. So over the last couple of days we've been talking about angles. A transversal is a line that intersects two other lines at different points. More importantly for us in Math 3, a majority of the time the transversal will go through a set of parallel lines. So on the screen you will see this weird symbol right here, or this little statement right here. It says M double line N. That just means that line M is parallel to line N. When you have a transversal, because here's your transversal right here. This will be your transversal, the line that cuts right through the parallel lines. Imagine it like a bridge. When you have a transversal that cuts through parallel lines, you have 8 different angles are created. You can see on the board, on the screen that I number them: angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, 7, 8. This time I went clockwise. It doesn't really matter how you name them, just as long as you understand the relationship. Please pause it, copy down the definition: transversal, a line that intersects other lines at different points, and then draw this diagram. So pause it, and I will continue on. Next, corresponding angles. Corresponding angles are angles on the same side of the transversal and have corresponding position. In other words, corresponding angles are same side, same corner of the transversal. If you look on the screen, you'll see I highlight or circled it in black and also in red. So angle 2 and angle 6 are called corresponding angles because they sit on the same side of the transversal and they also on the same corner or same section. And they're always congruent to one another, or in other words, they're equal. Okay, so corresponding angles, same side, same corner. So angle 2 is equal to angle 6. Because you can see that here they are in the, if you're tilting it, it's in the upper right hand corner, angle 2, and then going across the transversal, angle 6 is also transversal. And then angle 4 is a corresponding angle, it matches angle 8. If you haven't seen already, angle 1 corresponds with angle 5. So I can say angle 1 is equal to angle 5, and the last set will be angle 3 corresponds with angle 7. And those are corresponding angles. Again, if you need to pause it and then write down the definition and write down the example. Next, we have alternate interior angles. A lot of teachers, including myself, will abbreviate it for AIA, alternate interior angles. Those are angles that are congruent and they're opposite of the transversal and inside the parallel lines. So let's break down the phrase alternate interior angles. Alternate means either side, interior means inside the parallel lines, and then angles are your angles. So here, they always form an X, kind of like jumping across the transversal. So here, AIA, angle 4 is alternate interior angle. It matches angle 6 because they're across. And then angle 5 is alternate to angle 3. They are congruent. So one more time, alternate interior angles are angles that are opposite of each other across from the transversal. Okay. Last, we have alternate exterior angles. Now this is opposite of the interior angles. We'll call this the AEA. Okay, so AEA stands for alternate exterior. So exterior means they're on the outside. Alternate means on either side. So for example here, alternate, you have angle A is alternate in exterior angle matches angle H. You can look at angle B, which is right here. You would go across the transversal but on the outside. That would be angle B alternate to angle G. Okay. Okay, so here's an example. Draw this and then write this answer. Identify a pair of corresponding angles and a pair of alternate interior angles. So let's do the corresponding angles first. So corresponding angles would be, you just need a pair. So corresponding angle, this is going to be this top left corner, angle 1. I go same side, same corner of the other parallel line. So there's angle 3. So corresponding angle would be angle 1 and angle 3. Other examples you can have would be angle 5 and angle 7. You can go angle 2 and 4. You can go angle 6 and 8. So you listen angle 5 and angle 7, angle 2 and angle 4, and angle 6 and angle 8. Those are all corresponding angles. Alternate interior angle, I'll switch colors so you can see. Let's do bright green. Alternate interior means inside the parallel lines. Here's 2, go straight across the transversal. So A would be angle 2 and angle 7. The other pair would be angle 6 and angle 3. Angle 6 and angle 3. So those are your 2 pairs of alternate interior angles. Why do we need this? Because here's an example. Find all the angle measurement. Now we're going to pair out with complementary, supplementary angles, vertical angles, and we only need one angle measure and we can find all 8. So let's start with what we know. Okay, so let's start at 79. I know a couple things. I know that this straight line, this angle, and this 79 have to add up to 180. I also know that vertical angles, my favorite, straight across, is 79 degrees. So this angle, and this angle are 79 degrees. And then we can go 180. Okay, you can go 180. Just to double check your math here, minus 79. I know that that angle is 101 degrees. So opposite of that would be 101 degrees. There we go. This angle are called supplementary adjacent angles, add up to 180. 101, 101 are called vertical angles. Now, how do we find out the other ones? Well, we can go straight across the transversal, and this angle are alternate interior angle, and they are also congruent. Straight across. And these 2 angles right here, this angle and this angle are supplementary angles, so they have to add up to 79 degrees. But we also know, check this out, this bottom left corner also matches this upper left hand corner. Those are corresponding angles. So we have those straight across 79 degrees, straight across vertical angles are 101 degrees. So just because we know one angles and we have other properties of angles, we can find all 8 angle measurement. So that's all I have for today for transversal through a parallel lines. Make sure you write down the examples and please rewatch it and get the definitions for sure. We'll go over in class later.